Benzene was first extracted from coal gas by oil scrubbing in the 1860s by Badisch Company in Germany. It is probably the most thoroughly studied and best known of all organic compounds. One of the first important early uses of benzene was to manufacture phenol for antiseptic properties by reaction with sulfuric acid to form benzene sulfuric acid, which was fused with caustic soda to form phenol. By the 1930s, about 1.5 million tons of benzene was recovered worldwide from coal gas. World War II upset the traditional supply-demand balance and created a need to recover benzene from petroleum. Petroleum sources now provide 97% of the benzene. Benzene has many uses and demand continues to grow, despite increasing restrictions and environmental regulations. Production of styrene monomer is the largest use of benzene, followed by cumene, phenol, cyclohexane, and nitrobenzene. These derivatives are used to produce a wide range of plastics, fibers, resins, and films. Benzene is also an excellent solvent for waxes, resins, rubber, and various other organic materials, but toxicological properties greatly limit use. Benzene, like other aromatics, has a high octane number and was a valued gasoline blending component until its use was restricted by the Clean Air Act. The U.S. Department of Health and Human Services, DHHS, classifies benzene as a human carcinogen. Benzene may cause adverse health effects following exposure via inhalation, ingestion, or dermal or eye contact. Acute health events include myeloid leukemia and contact and/or allergic dermatitis. Delayed onset health events include potential decrease in the number, neutropenia, agranulocytosis of certain white blood cells in the peripheral circulation and in the bone marrow, aplastic anemia. This in turn has the potential to result in cancer of the red blood cells, erythroleukemia. Benzene is a highly regulated compound under OSHA, the Clean Air Act, and the Clean Water Act. The Occupational Safety and Health Standard for benzene as a toxic and hazardous substance is found in 29 CFR 1910.1028 subpart Z. This standard defines the roles of the employer and employee to control benzene exposure in the workplace. The National Emissions Standards for Hazardous Air Pollutants, NESHAP, are emission standards set by the EPA that were not covered under the existing National Ambient Air Quality Standards, NAAQS. The NESHAP standards are authorized by Section 112 of the 1970 Clean Air Act, and the regulations are published in 40 CFR Part 61. Benzene was one of the initial 7 compounds targeted under the Part 61 NESHAP standards, along with asbestos, 1971, beryllium, 1971, inorganic arsenic, 1980, mercury, 1971, radionuclides, 1979, and vinyl chloride, 1975. The specific Part 61 benzene regulations include control of emissions from equipment leaks, Subpart J, coke byproduct recovery plants, Subpart L, benzene storage vessels, Subpart Y, benzene transfer operations, Subpart BB, and benzene waste operations, Subpart FF. The EPA realized that producing regulations on single compound per process was not efficient. The 1990 Clean Air Act amendments directed the EPA to set standards for all major sources. These standards require that a particular source category require the maximum degree of emission reduction that the EPA determines to be achievable, which is known as the Maximum Achievable Control Technology, MACT, 40 CFR Part 63. The EPA published the initial list of source categories in 1992, and since that time has issued several revisions and updates to the list and promulgation schedule. Benzene sources were included on that list and have to comply with both the general and specific air regulations. The Clean Water Act, 1972, created the National Pollutant Discharge Elimination System, NPDES, permit program, which controls water pollution by regulating point sources that discharge pollutants into waters of the United States. Point sources are discrete conveyances such as pipes or man-made ditches. Industrial, municipal, and other facilities must obtain permits if their discharges go directly to surface waters. In most cases, the NPDES permit program is administered by authorized states. Permit limits are based on technological control standards and are designed to protect overall water quality of the receiving water body. Additionally, most stormwater discharges are considered point sources and require coverage under an NPDES permit. The primary method to control stormwater discharges is the use of best management practices, BMPs. The Safe Drinking Water Act, 1974, requires the EPA to determine the level of contaminants in drinking water at which no adverse health effects are likely to occur. Contaminants are any physical, chemical, biological, or radiological substances or matter in water. Maximum Contaminant Level Goals, MCLG, are non-enforceable health goals based solely on possible health risks and exposure over a lifetime. The MCLG for benzene is 0, which is not an enforceable level. However, the EPA has set an enforceable regulation for benzene called a maximum contaminant level, which considers cost, benefits, and the ability of public water systems to detect. The current MCL is 0.005 milligram per liter for benzene in drinking water. The Comprehensive Environmental Response, Compensation and Liability Act of 1980, CERCLA, is a federal law primarily concerned with the cleanup of sites contaminated with hazardous substances. The regulation also has defined procedures for reporting emergency releases of hazardous material. Upon release of a hazardous material above its reportable quantity, the U.S. Coast Guard, state and local officials must be notified within 1 hour. The reportable quantity for benzene is 10 pounds. Benzene is on the list of chemicals in the Emergency Planning and Community Right to Know Act of 1986. Section 313 of Title III of the Superfund Amendments and Reauthorization Act, SARA, requires owners and operators of certain facilities that manufacture, import, process, or otherwise use the chemicals on the list to report annually any release of those chemicals to any environmental media over a specified threshold level. The EPA used 1999 reported emissions data for all 50 states to model ambient air concentration and potential human exposure. Based on the estimated risk calculations, benzene was the only known carcinogen to meet criterion of a national cancer risk driver, meaning upper bound lifetime cancer risk exceeded 10 in a million to more than 10% of the U.S. population. Employers have the primary responsibility for ensuring that their personnel are trained appropriately and that their activities are compliant. The individual employee is ultimately responsible for being knowledgeable about the hazardous materials they work with and complying with applicable regulations. This information is intended to supplement an employer's existing health and safety program and should not be used as a substitute for expert safety and medical advice. While benzene is dangerous when handled improperly, benzene operations need not be hazardous, providing the hazards are recognized and handling instructions are rigidly observed. Any person handling benzene should be sufficiently trained in the handling techniques, have specific first aid instructions, and equipment available for use in the event of personal contact or exposure.